Good day, ladies and gentlemen. You're welcome to my YouTube channel. Today we'll be treating determining the formation of images by convex lens. This was what was prescribed for us, the apparatus that was prescribed for us for this practical. This is the likely question that you are going to see for your Waec 2021 question on light. So please, I want you to listen based on what they say we should provide. That is what I'm carrying this practical out. So we are determining the formation of images by convex lens. The apparatus that was prescribed for us is ray box with an illuminated light object, cross wire. Then we have number 2, the convex lens of focal length 15 centimeters. We have the screen, and we have a meter rule to have lens holder. I'm going to show us the various apparatus as listed here. So number 1, this is a ray box, and you can see the illuminated object coming out of the ray box. Then the convex lens, this is a convex lens that we are using. Our focal length of the convex lens is 15 cm. So make sure for this practical that the focal length of the convex lens is 15 centimeters. This is a lens holder. This is a meter rule. Of course, you know what meter rule is. Then, and this is the screen. The essence of the screen is to view the image formed from projecting this illuminated object from the ray box. So we are going to do that. So let's look at this question. This was 2018 Waec question on light. They gave us this experiment and they said we should set it up like this. This is a ray box, and of course this is the illuminated object coming out of the ray box. And the diameter from here to here is to be recorded as A0. So the diameter of this should be A0, which I'm going to record. Then this is the lens. This is our lens. This is the screen. Then the image that is formed as a result of the projected light passing through the screen, we are going to record A. It will be called A, which stands for the diameter of the image formed on the screen. So you are provided with a meter rule, the lens, the screen, the ray box, and other necessary apparatus. Set up the experiment as shown. Record A0 of the illuminated object. So that's what we are going to do. This is our illuminated object. The hole here we are going to measure. So I'll use a ruler to measure this. From my ruler here, the ray box, the diameter of the ray box A0 is 2 centimeters. So we are going to record A0 as 2 centimeters. So in our table of results, we'll have our A0 equal to 2.0 centimeters, which stands for the diameter of the light that is being projected from the ray box. So please, let's take note of that. Okay, let's proceed. The next thing we are saying to do is the distance between the ray box and the screen is recorded to be x, while the distance from the screen from the lens to the screen is v. So they say we should place the object at a distance x 25 cm. So our first value is to place the illuminated object at this point 25 cm. So we'll have our table of results. The first thing here is what they say we should do. So we are going to check 25 centimeters. So let's do that. This is our meter rule. We are going to place the illuminated object at 25 centimeters. So okay, So the distance between the ray box, which projects the illuminated ray, to the screen is at 25 degrees, as we can see now. So I will make sure that the projected light is coming out. Okay. Okay, so we are going to measure 25 centimeters, the ray box, from the ray box to the lens. So this is at 25 centimeters. And from here to here is the object distance, known as U. The object distance U. Then from here to here is V, is called the image distance. So what we are going to do is we are going to adjust the screen till we get a bright image that is formed on the screen. So that's what we are going to do. At 25 cm, they said from the lens, adjust the screen until a sharp image is obtained on the screen. Measure and record the diameter A of the image formed. So we are still going to record the diameter of the image formed in this screen. So that's what we are going to do. Then, you know, our A0 was gotten as the initial object, as the initial diameter of the illuminated object. So we are still going to measure the diameter of the image formed in the screen. Okay, so let's measure that. But first, we'll make sure that we obtain a sharp image on the screen. And by adjusting the screen, you will see that these points, at these points, we are obtaining a sharp image from the screen. Of course, you can see it, there is a sharp image. So what I'm going to do now, for us to get our A, I'll measure the diameter of the sharp image here. So I place my ruler at this point. Okay, so I now get that the diameter of this image formed is 2.6. So at 25 cm, the diameter of the image formed on the screen is 2.60. So I'm going to record it that way. So the next thing said, measure and record the diameter of the image, which we've done. Then they said measure and record the distance V between the lens and the screen. The distance V now is between the lens and the screen. This is our lens and this is the screen. So I'm going to take note of the distance from here to here. Of course, as I'm seeing here, is from here to here, the distance from here to here is gotten as, from here is 75 and here is 23. 75 minus 23. 75 minus 23. We'll have 52. So our V here, which is the image distance, is 52. So I've recorded that. They now said evaluate Y is equal to A over A0. Please note that A0 is the diameter of the ray box, the diameter of the projected image from the ray box, and our A is the diameter of the image formed on the screen. So we are going to, they say we should evaluate y to be a over a0. So look at it here. Y is equal to a over a0. So let me use my calculator to calculate that. Y is equal to a over a0. Our a is from the 25 cm is 2.60 and our a0 is 2 cm. So a over a0 is 2.60 over 2. So we are having 2.60 divided by 2. We are having 1.3. So we are going to record 1.30 for the value of our y. Then we are going to evaluate p. They say we should evaluate p. Evaluate p is equal to 1 plus y squared over y, and t is equal to x plus v. So for 25 cm, our a, which stands for the diameter of the image formed on the screen, and our v stands for the distance between the lens and the screen. That's how we got 52 here. Then our y is a over a0, which we got as 1.30. Then to evaluate our p is equal to 1 plus y squared over y, which we are going to do. P is equal to 1 plus y squared over y, which will have 1 plus, our y is 1.3. So this will be 1.30 squared over y, which is 1.30. So I'm going to use my calculator to do that. We'll have 1 plus 1.3 squared will give me 1.69 over 1.30. So I'll have 1.69 plus 1.30 divided by 1.30. I'm going to have here to be 2.30. They also say we should evaluate t equal to x plus v. So our x is what? 25 plus v. Our v is what? 52. So we are doing 25 plus 52. And we'll have 77.0. So we are going to repeat the experiment for x to be 30 cm. This. The first one we did was x to be 25 cm. X stands for the distance between the ray box, which houses the illuminated object, from the lens. So now we are going to move the distance to 30 centimeters. So I move it to 30 centimeters. Okay, it's now at 30 centimeters. So I'm going to adjust my screen till I get a sharp image on my screen. So that's what I'm going to do. So if you watch, you will see that when you are adjusting your screen, you obtain a sharp image at this point. Of course, you can see that we are getting a sharp image at this point. So what I'm going to do is to measure the diameter of the image formed on the screen. So that's what I'm going to do next. With a ruler, I will measure the diameter formed by this. So measuring the diameter from here, I'm getting the diameter 2.4. So that's what I'm going to record here. The diameter of the image formed is 2.40. And I'm going to calculate my V as the distance between the image and the screen. So I'm going to record that now. So from here to here, here is at point 70, then 70 minus 26 will give me my V. 70 minus 26 will give me my V to be 44.0. So the same thing, that is what you are going to do. to evaluate our y. Our y is a over a0. So I'm going to have y is equal to a over a0. So I'm going to have 2.4 divided by 2. Please take note that our a0 is 2, which is the initial diameter of the illuminated object. So we'll have 2.4 divided by 2, and we'll have 1.20. So what I'm going to record here is 1.20, and I'll still evaluate my p. P is equal to 1 plus y squared over y, which is equal to 1 plus y is 1.20 squared over y is 1.20. So I'm going to have 1.20 squared plus 1 divided by 1.2. And I'm having 2.03. Then I'll evaluate my t. My t is equal to u plus v. Or is equal to x plus v, sorry. And our x is what? The x is 30 plus our v, 44. So we are having 30 plus 44. That will give us 70. 30 plus 44, that will give us 77.0. So we'll proceed for all other values of, we are going to proceed for all other values of x at 35.0 cm, 40.0 cm, and 45.0 cm. Please note that at each case, the only thing that you need to do is to project to move your lens to 35 centimeters away from the ray box. That is the projected ray light. Make sure it's at 35 centimeters away from it. Then you now measure, you now get the diameter of the image formed on the screen when it has projected a sharp image on the screen. So after doing that, you obtain the various values of A to B. For this one, you have this to be 2.10, and you have 1.80. That is the value of A, which I say that A is the diameter of the image formed on the screen. I've recorded it. Then we'll have this to be 1.60. Therefore, 35, the V, which is the distance between the lens and the screen, as shown in the diagram. The distance between this lens and the screen, at the point at which the screen has formed a sharp image on the screen from the projected light being passed through the convex lens or focal length 15 centimeters. So please note that. So the value for our V would be 43.0. No? Yeah, 43.0. Then the value for this will be 40.0. Then the value for this will be 39.0. Alright, so we are going to calculate for our values of y equal to a over a0. So y is equal to a over a0. We'll have our a 2.1 over 2 divided by 2. We'll have, yes, 1.05. We'll have this divided by 2. 1.8 divided by 2. We'll have here 0.9. We'll have this divided by 2. 1.6 divided by 2. we'll have 0.8. We'll get the values of p, which is 1 plus y squared, 1.05 squared plus 1 divided by 1.05. We'll have here to be 2.00. Then this 0.9 squared plus 1 divided by 0.9. We are having here 2.002. Then here we are having, this is a over a0, okay, 1.6 divided by 2. Here is 0.8, so we are having 0.8 squared plus 1 divided by 0.8. We are having here 2.05. Okay, so we still get individual values of x plus v. X plus v is 35 plus 43 will give us 35 plus 43. That will give us 78.0. Then we'll have 40 plus 40 will give us 80.0. 45 plus 39. 45 plus 39 will give us 84.0. So we have gotten the values, all the values that was saved for us to get in the table. So let's listen to the question. Tabulate your results. We have tabulated our results. So we should plot a graph of P on the vertical axis and T on the horizontal axis, starting both axes at 0, 0. So what we are going to do is this will be the P will be on the vertical axis. This is our values of P will be on the vertical axis and our T on the horizontal axis. So what you are going to do is you choose a proper scale, plot this graph of P against T. Are we good? Then we are now told to determine the slope S of the graph. Of course, we know how to find the slope. Change in P over change in T. Change in P over change in T. And it's also said we should determine the intercept on the horizontal axis. So after plotting your graph, it is said that the graph will cut through the x-axis. So we are going to obtain the value for your intercept, which is C. Then so to evaluate K is equal to C over 2. So whatever thing that you get as your intercept, divide by 2, that will give you K. Then the next thing they say, okay, they say we should take 2 precautions taken to obtain accurate results. The first thing that you need to note is this is a live practical. You need to be very careful when taking readings on the image. The image form, to know the diameter of the image, you have to be very careful so that you avoid error due to parallax when taking reading with the ruler that you are using. Then you have to also make sure that the illuminated object, the object is placed at the rightful position before commencing any practicals. So I hope and I believe that we have learned a lot from this simple demonstration of these practicals. Please, if you like my video, subscribe on my YouTube channel, click the link on the description below, subscribe, comment on my video, like and share, as I'll also be posting a lot of videos concerning our practicals in Waec 2021. So stay tuned and remain blessed. Thanks.